So let's start with the basic syntax from Kotlin. As you can see, we can declare flare functions with the function, let's say with 0 parameters, and that this has a name, my awesome, or print hello world. It has a unit, return type. If we are not going to return anything, you can use unit. In any case, you can also omit it. And now we have a function that can be called from anywhere else. This differs of popular object-oriented languages in the case that functions are actually a first-class citizen. We can call them from actually anywhere. So, like for example, we can say print hello world and move this here, and now we have our same functionality, but in um, in an external function. We could also pass parameters. In this case, we could say we're going to pass a, a salutation, and we can actually interpolate in this word. We can interpolate this with that salutation, and we could pass that parameter saying hello world. We can actually run. So at this point, we can see two things. We can declare functions. We can also see how we're declaring parameters. And actually, this is the way that you declare also variables in functions and things like that. Uh, at the end is the name and the type. Name, 2 points, and the type. If the function has a return type, and then you have to express it. So let's say we have a function that is calculate salute, and we are going to pass as something that is like the salutation, the same salutation that we have here, and this is going to be of type string, and this is going to return a string. So in this case, we want this to return string, and that actually will return this string. If we were going to say this, it's going to fail because it doesn't understand. You need to explicitly say what's the return type to make it type safe. So at this point, we can actually rename to, no, we can actually calculate the salute and print it from here. Again, this is not actually a program that will do anything useful, but it's to understand what the syntax is. So at this point, we know how parameters work, how functions with return type work, and we can go from there. I have a typo here, so I'm going to fix it. And now we know how functions with return types work. Now let's go to the next thing, and it's basically how do we declare values and variables. So Kotlin has the val keyword that is a value that is actually read only. So let's call this again salutation, and we're going to do it world itself. Whoops. Um, Now we could actually pass this on this code, and we have the salutation as a value. What will happen if we try to do this another value? Well, it's going to fail because it says that it's a value. For this, Kotlin actually allows you to declare variables. So variables are done with the variable keyword, and it allows you to basically change the value itself. Normally, if we're talking about immutability, you won't want to use values as much as possible. So, you don't want to use variables as much as possible. You want to probably have values and assign them to something else. You could actually also defer the assignation of a value. Like, for example, if we say that this is a string uh, and we don't assign it on this line, we can actually do this as salutation. Now it's telling me that what I'm doing doesn't make a lot of sense and I can actually assign it here. But this is actually useful if you're only going to assign it once and you have some logic depending on how you're going to assign this variable. Other important feature of Kotlin is that it's null safe. It's not it's not only type safe, but it's null safe. What does that mean? Actually, let's make this a variable. In other languages that are object oriented, you can actually assign a null to this value. In the case of Kotlin, this is not allowed. Why? Because it's null safe. You actually need to declare it as a nullable value for it to allow uh, a null value. And again, even if I declare the variable as a nullable value, the propagation of that value needs to comply with that nullable. So, like for example, in my print hello world, it's not accepting the salutation because it's not actually a nullable string. This saves some time and saves some readability and issues that could exist due to the possibility of a null value. So in our case, we don't want a nullable value. We can remove that nullable value. But the important thing to know is that actually Kotlin is null safe. Another abstraction that exists in Kotlin are classes. You can actually declare a class. Uh, let's move now to the idea of a point. And this point is going to have an x coordinate and a y coordinate. And now you have a class itself. At this point, if you declare a function inside this, the function calculate difference, and you receive a point. Uh, you can actually not access dx from your current point. So how do you create this value that is part of the instance of this class? Well, again, if you want this to be a static value, you can just declare it as a val. So now you can say x, and you have access to that value itself. So then you can return um, some the difference in x, or x minus point dot x, because at this point we have said that there's no accessor, or we're not making this private. We could actually make it private, uh, and at this point we'll probably not have access to it. But the thing is, the intent is you can declare your class variables, properties, however you call them, in the in the parameters from the class. So all your variables are at this level. You can also declare another one that is, I don't know, zoom, and I don't know why you would do it, but this could be x plus y, and this will be also accessible at the class level. There's a special type of class used quite a lot in Kotlin that if you're actually working with immutability and you are not actually going to have uh, a an object that is going to have state and is going to be muted in that state are actually data classes. Data classes are exactly what that means. Are classes that don't have internal functionality, but actually declare some values that are going to be used. And it's an abstraction that we want to use to hold the state that we were talking on our first chapter. Okay, now let's just go very fast over the common logical control um, functionalities that you can have. Like in any language, you can always have an if that you could say if a value to test is equal to true. It doesn't, of course, have a lot of logic. Then I do salutation equal uh, world, and in other case, I do salutation equal to other. As you can see, this is basically as a logic, an if else logic. You could actually inline this, so you can actually say if this, else this. And just assign it here. Well, almost, because I need to have the test declared before. So yeah, you can use it as an expression, and you don't need to have the brackets or anything else. Now, if you have a list of items like val possible salutations, and I can put here a list of, then I'm going to say world person and other. If I would like to do a for loop, the thing that you need to do is declare it with a for. I do possible salutations, salutation, because the first one is the item that I'm going to be using in the possible salutations. And now we can actually do a print line of this salutation. There's also a while loop that we could use. So we can do a while index. Now we actually need to go by index. So this needs to be a variable index because it's going to be actually changing. And we're going to start at 0 while the index is below the possible salutations dot size. Then, like it's a multi-line, I need the brackets, and now I'm going to do a print line of my possible salutations. I'm going to access it by the index because we still can access at least by index like in any other language. And that's actually it. And now we just need to increment the index. And this is a while loop. So now we know the different type of loops and what kind of control we can actually have for logic. Nevertheless, this is something that most of the languages have. Nevertheless, the most interesting functionality that Kotlin has on this kind of control is the when. When either even if it's similar to a switch statement, it's more powerful than that. So let's say we have a number here. So let me say val number, and for now we're going to give it just a random number for now. So what can when actually do? When, even if you could say, think it's a, a switch statement, it's actually not. It's in between a switch statement and a pattern matching. So because we can say if the number is zero, then print and nothing. But we can actually do things that are more complex actually than this. So it could actually be in one until three. So we can declare actually a range of values, and we can say uh, print line uh, less than three, more than one. Less than three, more than zero. And we can also do an else statement that will be a kind of catch-all. And we can say a print line of unknown. So as you can see, it might look as a switch statement, but it's not completely a switch statement. That is why it's called when. And this is some of the difference there. Let's clean a little bit this code. We're going to be talking now about collections. What can we do with a collection? So going back to our last keyword, we can actually do a few things. We can even use a when and actually say world is in our possible salutations, then do something like print line of that hello world. And if orange is in that possible salutation, then do print hello orange. As you can see, the first one will execute, and the second one will not because there's no orange there. This is a way we could use this when statement. Nevertheless, if we talk about functional programming, what functional programming normally tries to do is do transformations over existing data. That's why collections are something important. We have a list here that is actually a collection, and we can actually do some work over it. So, for example, under possible salutations, we can do certain transformations like, for example, I can filter the ones that it starts with a certain prefix. So let's say the ones that start with W, and then we can sort them by whatever we actually want. This is an iterator. Um, we can transform things again, so we can map this string into, for example, a lowercase. So everything is actually a lowercase. Um, and then we can do something for each of them that is that print line of that word. And what will happen is that what we did was all this all these different executions, to put a name, over the collections that we were uh, talking about. Of course, at the end, it's not returning anything, but if we basically just leave it till the map, then we'll actually can return a different collection. So we can even change this logic, and now you see only world was printed. Now world will be the only one that is removed. So this is how actually the intention of functional programming is we're going to be transforming data, but we're not going to be mutating it itself. We're going to probably assign it to something different. Let's just do that for a second. So we're going to remove this. We're going to uh, put this to salutations, and we're going to do for each of these salutations, we're going to do a for each. We're going to do a for each, and we're going to call this print hello world with the iterator that we have before. So with this, we can actually do a cleanup of our code and say that the final code that we're creating is we're creating a list of words. That words we're filtering the ones that start with W. So only person and the other will stay. They're going to be sorted by the characters, and then we are going to convert everything in lowercase, and then this P and this O are going to be lowercase. At the end, what will happen is we're going to do something for each of the salutations that the collection keeps, and that's going to just call the function that we've created on the first time. And let's then just, for the sake of what we're actually doing, let's call a class salutation and call this the val salute, and this is going to be a string, and we're going to map this into a salutation of the iterator itself. So now we have the salutation, and then we can actually not pass strings here and do this and Basically, now we're using all the different things that we've learned today, uh, talking about collections, transformation of collections, functions, with or without return value, and data classes to actually encapsulate things. If we run this, we now have the hello other and hello person itself. Hope you have enjoyed. So, hope also to see you in the next chapter, where we will be talking a little bit more in depth of concepts of functional programming and how they are used in